Hello everybody, my name is Christian Daniel, and today I'm going to be showcasing my latest project that makes use of the Unity engine, an Arduino Nano with motion tracking and Bluetooth capabilities, and any Windows device with Bluetooth support. Let's get into it. As you can see on screen, as I move the paddle around, the motion captured by the Arduino is transmitted over Bluetooth Low Energy to Unity, which applies that motion to an in-game object. When I first thought of making a motion controller, the first idea that popped into my head was a ping pong game, which I've quickly put together here. Before I show you the design of the game, allow me to showcase the paddle device. First and foremost, to allow access into the inner components, I modeled doors on the back that can open and close. There are two separate 3D prints that make up the design: the paddle section, which houses the Arduino, and the handle, which houses the battery circuit. A hole runs through both parts to allow wiring between the two sections. The battery circuit includes two 3.7-volt lithium-ion batteries, a TP5100 charging module, a 5.5 by 2.1mm female DC connector, a slide switch for power, and of course, a fair bit of wire and solder. Here you can see the charging circuit in action. You can charge the batteries while simultaneously powering the Arduino. All of the 3D models, diagrams, software, and instructions for the project are located in the GitHub repo, which is linked in the description. After downloading the zip like so, and extracting the files, we can go into the STL folder and open up the circuit diagram I created for the battery setup. Well, maybe it's better I show you the mockup so that we can understand some of its quirks. As you can see, the negative input and output of the TP5100 module both need to connect to the Arduino's negative input to ensure stable power draw during charging. Since both pins go to the same negative input, I realized that I could simply bridge them directly on the TP5100 itself, reducing it to only one wire going from the battery to the Arduino. Later on, I learned that the optimization I discovered is known in electrical engineering as a common ground, and that was pretty cool to me. Next came the Arduino sketch. I started by downloading the Arduino IDE and experimenting with example sketches for reading accelerometer, gyroscope, and magnetometer data. I also looked at an example showing how to send and receive LED data over Bluetooth. The challenge was combining all of those data reading and Bluetooth sketches into one, a program capable of sending packets of motion data fast enough for accurate in-game recreation. But with a lot of hard work, dedication, and frustration, I eventually got it done. Next up on the list was figuring out which game engine I wanted to use to make my game. I looked at Unreal, Game Maker, Godot, but none of them really had what I need to connect the Bluetooth device. But that's when I came across the BLE WinRT DLL plugin for Unity, created by, I'm sorry if I get your names wrong, but Adam Brunmeyer, Abraham Hamidi, and Eric Hauner. A really big thanks goes out to you three and all of the Repo's contributors for making my project possible, because it really rests on your shoulders. Their API shows how to scan for Bluetooth devices, connect to them, and send or receive data through Windows' native Bluetooth stack. I essentially built my entire game around their API, so a huge shout out for making it open source. Once I had the Arduino sketch and the base software in Unity ready, it was time to build the game itself. Initially, the plan was to make a player versus player ping pong game, but managing just one Bluetooth device was difficult enough. So I ended up making it a one-player game focused on returning balls served by the CPU. There are three main scripts in my Unity project: BLE Manager, IMU Manager, and Game Manager. BLE Manager runs the Bluetooth API, discovering devices, connecting to services, and reading incoming data continuously. IMU Manager filters and applies the IMU data to the in-game paddle. And Game Manager handles game states, scoring, and UI. To connect the paddle, you simply power it on near your computer and run the game. Once connected, the LED on the Arduino turns blue and the play button in the game becomes interactable. Press it, and the game serves 10 balls to your side of the table. Your goal is to return as many as possible without hitting the front side first. The game's music was made by me, and the models were downloaded from free 3D model sites, and huge W to anybody that can understand Blender. Now let's talk about some challenges that I went through during the making of this project. First off, double integration, which is the nightmare of anybody working with digital motion. IMU sensors like accelerometers and gyroscopes measure changes in motion, and we can integrate this data to get orientation. But to get position, we need to double integrate, which amplifies even tiny errors exponentially. Without an external reference, position data from IMU becomes extremely unreliable. To get around this, I realized something. In ping pong, your paddle's motion is mostly rotational, forehand and backhand. So I map paddle yaw to lateral movement. If you're right-handed, yaw greater than 0 means the paddle is on the right. Less than 0 means it's on the left. And if you're left-handed, it's the opposite. It's not super physically accurate, but it's responsive and fun to play. Another issue was the magnetometer. These sensors are very sensitive to magnetic fields, and since I stored my paddle on top of my PC next to my speaker, the voice coil in the speaker, which creates a strong magnetic force, completely ruined my magnetometer. I had to rely solely on the accelerometer and gyroscope data from then on, which led to less accurate motion data. So, in the end, I was still able to make a functional, responsive, and most importantly fun game that combines software and hardware in real time. That's it for my project. Thank you for watching.